I welcome everyone to this part 2 of the titration training. This lesson video covers measuring mass and standard solution. The person you are hearing his voice is Emmanuel Ezewani, a master degree holder in food and industrial microbiology, obtained from Federal University of Technology, Owerri, a food safety and quality evaluator, and a chemistry teacher in Federal Government Girls College, Onitsha. We are about to begin, and you are expected to have your pen and book ready. We are starting with measuring mass. In titration, two substances in aqueous solutions react with each other. For example, acid and base. Concentration of one of the solutions is known, while the concentration of the other solution is unknown. For the solution with known concentration, the standard solution of the substance, you have to be prepared by first measuring the mass of the substance. To measure the mass of the substance, we use weighing balance. Other apparatus needed for this operation are weighing pan and spatula. We can weigh the mass of the substance by following the steps below. 1. Place the weighing pan on the balance and press tar. Pressing tar helps the machine to ignore the mass of the pan by resetting it to 0. After pressing tar, use your spatula and add little quantity of the substance into the weighing pan until the desired mass is reached. When you reach the desired mass, you pour the measured substance into a beaker. For your project, the positive signs you see here help you to add the substance into the pan. The bigger the positive sign, the higher the quantity you are adding. So take notes. Okay, let's now look at standard solution. In titration, two substances in aqueous solutions react with each other. We have said that before. Concentration of one of the solutions is known, while the concentration of the other solution is unknown. The solution with accurately known concentration is called standard solution. For example, we have 0.05 mole per dm cube of sodium hydroxide. Types of standard solution. We have primary standard solution and secondary standard. Let's look at primary standard solution. This is a solution of known concentration prepared from pure, non-deliquescent and non-hygroscopic substance. The substance does not absorb moisture during weighing. When you want to weigh it, you have to expose the substance. So the substance that you need for this standard solution should not absorb moisture when you expose it to atmosphere. Example, solution of sodium triazoocarbonate 4. Secondary standard solution. It is a solution of known concentration derived from primary standard solution. They are not very pure. The substances used are deliquescent and hygroscopic, so they absorb moisture during weighing. So the solution will have to undergo further standardization using a primary standard solution. Example, solution of sodium hydroxide. Materials needed to prepare a standard solution. We have beaker, volumetric flask, a funnel, water container, example, wash bottle, what to do if you want to prepare a standard solution of a substance. First, weigh accurate mass of the substance. Pour the measured substance into a beaker. Add little water to dissolve it. Pour the dissolved substance into the volumetric flask. Add little water again into the beaker to rinse it and pour the water into the volumetric flask again. Finally, add little water directly into the volumetric flask to make it up to this mark. Can you see the volume mark? Okay. Let's see the demonstration. Okay. Here, we want to prepare the standard solution of sodium hydroxide. Please always read the instruction provided here before you begin. First thing I will do is to dissolve the solid substance that is in this beaker. To do that, I have to add water into it. If you are working in the lab, a real life lab, after you have added the water into this beaker, you have to use stirrer, a stirrer, and stir. You stir it very well to ensure that the solid substance will dissolve completely. So, but here in this program, we don't have a stirrer. As soon as you add the water, the solid substance will dissolve completely here. But if it's a live activity you are doing in the lab, you have to stir. I hope that is clear. Okay, so I'm going to add the water by dragging the wash bottle into the work space. So I will click on the positive sign you are seeing there. It helps to add water into it. You can see the water is added. So I'm going to bring the funnel and place it on the volumetric flask. Are you seeing that? Okay. So once I've placed the funnel, I will now drag the beaker on the funnel. Are you seeing that? Okay. So I will leave the funnel on the volumetric flask, and I will add another water into the beaker. This what I'm adding to the beaker now is to help rinse the beaker. So now I'll drag the beaker again and pour it into the volumetric flask. Did you see what happened there? The program shaked the volumetric flask. This is exactly what you do in your life, in your real life activity. After pouring that solution into the volumetric flask, you shake to have a uniform solution. So at this point now, you can see that it is close to the mark. Are you seeing the mark? So at this point, you add little water, drop by drop, into the volumetric flask so that you can get to the mark easily. Adding a lot of water at once will make the water to exceed the mark. You don't have to exceed the mark. Look at the volume of the volumetric flask we are using. It is 250 centimeter cube. So if the water you add exceed this mark, it means that the volume of the solution is more than 250 cm cube. But if it is below the mark, it means that it is less than 250 cm cube. If it's at the mark, it is exactly 250 cm cube. So to ensure that you get it to the mark, not above the mark, you add a drop of water. So I will drag this into the working space and on the volumetric flask. So I'll start adding the water drop by drop. So you can see. So this last drop, it should be at the mark. Yes, it's at the mark. Let's check. Good. Did you see that? So you click on finish. Take it to the next activity. We have come to the end of part 2 of this training. I hope you love it. Bye for now.